So why do we care? Okay, so one of the things is, I mean, we can figure out what makes our foods taste the way that they do, but it actually has a chemistry link and blood types. So blood types A, B, AB, and O, they're determined by the terminal or the end saccharides that are attached to the surface of red blood cells. So for type O, you can see it's like this. Type A is like this. Type B is like that. So this is why O is the universal donor, right? Because they're both good. So you can see that the pink is going to be a galactose. So type B has a galactose on the end, where type A has an N-acetylgalactosamine. Okay, so anyway, but it's going to be different. So blood type O has 3 common terminal monosaccharides: N-acetylglucosamine, I knew that word, glucosamine, galactose, and fructose. A contains the same 3 monosaccharides, but in addition, it has a molecule of N-acetylgalactosamine, and this is attached to the galactose in the saccharide chain. B also contains the same 3 monosaccharides, but in addition, a second molecule of galactose is attached to the saccharide chain. And AB consists of the same monosaccharides that are found in blood types A and B. So the structures of monosaccharides, N-acetylglucosamine, galactose, and fructose are as follows. First, type O, again, I just told you this, right? So look at the end and see what's different. So persons with type O blood, they contain the 3 common monosaccharides. They produce antibodies against blood types A, B, and AB. Therefore, they are the universal blood donors. Types A, B, and AB can receive type O blood. Type AB blood, which contains all the terminal monosaccharides, produces no antibodies to type A, B, or O, and therefore they are universal recipients. So sometimes this gets mixed up in media, right? So recipients are different than donors, all right? So anyone can get type O blood because it's good for everything, but AB can get any type of blood, but people say that AB is the most common, but I think it's actually A positive is the most common. But regardless, there is a difference between a donor and a recipient, okay? And so here is a fun little chart about the compatibility of blood groups. Okay, so here is another study check. So molybdenose is a disaccharide that is 30 times sweeter than sucrose. What are the monosaccharide units in molybdenose? What type of glycosidic bond links the monosaccharides? And identify the structure as either alpha or beta molybdenose. Okay, so pause me and come back. All right, so molybdenose is a disaccharide that is 30 times sweeter than sucrose. So the first monosaccharide on the left is when the OH group on carbon 4 is drawn, so we're analyzing the problem, right? Second monosaccharide on the right, the type of glycosidic bond, the position of the isomer, and then the name, okay? So how did we solve this? Well, what are the monosaccharide units of molybdenose? That would be an alpha-D galactose and an alpha-D glucose. What types of glycosidic bonds link the monosaccharides? And that would be an alpha-1,6 glycosidic bond. And then what is the structure? Either alpha or beta. And this is alpha molybdenose. Okay, great job.